Good evening, everyone. My name is Ganesh Thakur, Distinguished Professor of Petroleum and Mechanical Engineering at the University of Houston. And I serve as the Vice President of TAMEST. I want to welcome you all to the 2024 Edith and Peter O'Donnell Awards Dinner and Ceremony. We would like to take a moment to thank our O'Donnell Awards ceremony sponsor, the O'Donnell Foundation, for their support of this program. We are fortunate to have O'Donnell Foundation CEO Bill Solomon here with us tonight. Thank you, sir, for making this program possible and your ongoing support. Thank you. We would also like to thank all of our sponsors for their support of this conference. So all the sponsors, sincerely thank you. TAMEST would also like to thank donors of the TAMEST Endowment and O'Donnell Endowment for making this program possible. The TAMEST Endowment was created by Larry Faulkner and Kenny Jastrow with the help of Senator Hutchison. We are honored to have them here tonight, and we sincerely thank them for their vision and dedication in developing the endowment. Thank you all very much. Now I would like to invite all the award recipients to come onto the stage, please. All the award recipients, please come to the stage. We are honored to have our host this evening, Jere Thompson, Chair of the Southwestern Medical Foundation's Board of Trustees and board member of the O'Donnell Foundation. Mr. Thompson, thank you for hosting the ceremony. Mr. Thompson, please.
Good evening. Thank you, Dr. Thakur, and thank all of you for being here tonight. We have so much to celebrate tonight as we recognize these first-class innovators and scientists. This ceremony is a unique gathering of the Texas research community. With us tonight, we have university presidents, chancellors, CEOs, and many distinguished engineers, scientists, and researchers. The Edith and Peter O'Donnell Awards recognize rising Texas star researchers who are addressing fascinating scientific and technological questions, and whose work meets the highest standards of exemplary professional performance and creativity. And the awards are named in honor of the late Edith and Peter O'Donnell, who are among Texas's most devoted advocates for excellence in scientific advancement and STEM education. The awards represent a way to recognize young researchers at a critical stage in their careers and raise the profile of what's being done in the state. Since this program began, 16 O'Donnell Awards recipients have been inducted into the National Academies, and 4 of them have been elected to multiple academies. With us tonight are several past recipients of the Edith and Peter O'Donnell Awards, and we're so proud of each of you. If you're a past recipient of an O'Donnell Award, please stand so we can recognize you. Thank you. The awards are special because they are selected by National Academy members in Texas and approved by a panel of Nobel and Breakthrough Prize laureates. It's a highly competitive and prestigious award. We'd like to recognize the 2024 Awards Committee, chaired by Dr. Oliver Mullins, for their hard work in selecting these outstanding candidates. We'd also like to thank the Nobel and Breakthrough Prize Laureate Committee for their service. We can give them all a hand, please. We'll now celebrate the 2024 recipients of the Edith and Peter O'Donnell Awards. We're grateful to have their nominators and leaders from their institutions here with us tonight. The recipients will first be briefly introduced by a leader from their institution, followed by a video highlighting their work. We will then hear remarks by their nominator, followed by remarks from each of the award recipients. To introduce the first recipient, please welcome Dr. Mary Dickinson, Senior Vice President and Dean of Research at Baylor College of Medicine, to the stage. Dr. Dickinson.
Good evening, everyone. On behalf of the leadership and faculty at Baylor College of Medicine, we want to express our deep gratitude and pride in the recognition of having TAMEST recognize Dr. Ben Dineen as a recipient of the 2024 Edith and Peter O'Donnell Award in Medicine. Truly an honor. We are indeed grateful to the O'Donnell Foundation and the founders of TAMEST for making this award possible. Dr. Dineen is a professor and the Dr. Russell J. and Marion K. Blattner Chair in the Department of Neurosurgery at Baylor College of Medicine. And he has been nominated by two nominators, Dr. Malcolm Brenner and Dr. Helen Heslop, and I'll introduce Malcolm in a moment to say a few words. But I wanted to share with you that when Ben was recruited here in 2019, as you'll recognize if you get to know Ben and talk to him, that he has an irrepressible enthusiasm and excitement for science. He's a big idea guy, and he loves to pursue these ideas with a lot of zeal, sometimes even on foot, as you'll see in a moment. And at this point, we'll cue the video so you can learn more about his science, but it's been my absolute pleasure watching him grow and mature and really have so many successes. So again, we're truly grateful for this.
I run every morning. Physical activity really helps calm me. I need those 25, 30 minutes in the morning just to sort of hit a reset and think deeply about things that I otherwise wouldn't be able to do in lab. The brain is a very complex organ. The main cell type that people have focused on for a very long time are neurons, and I'm sure everyone has heard of neurons. But the other half of your brain is comprised of these cells called glial cells. Glial cells are essential for brain function. Glial cells communicate with neurons. These lines of communication play an essential role in everyday behaviors, and when these lines of communication are disrupted, it causes diseases and a host of neurological disorders.
Ben has focused on a type of cell called the astrocyte and really shown it's more than just an accessory cell that sits in the brain, that it has various important roles.
They're implicated in any and every brain disorder and disease.
We know that they're there, we know that they're important, but we have no idea what they do. And we're just now beginning to understand the language between an astrocyte and a neuron is essential for brain circuit function. If that language, that line of communication is disrupted, the entire circuit falls apart.
Knowledge of neural circuits might lead to ways that you can manipulate them to treat various brain disorders ranging from multiple sclerosis to Parkinson's to Alzheimer's and then to brain cancer.
Brain tumors steal your identity. It's like a spider web in your brain. The surgeon can take out the core, but you have all the tentacles everywhere else, and it's really hard to control it.
In order to find a cure, you have to know what you're trying to fix. And to know what you're trying to fix, you need to understand how things work properly before they get messed up. And so that's really what we do here. What are these critical functions of these cells? And it's, well, what happens when those critical functions go wrong?
We have a particular focus on brain cancer. In the 7 decades that we've been studying it, there haven't been major substantial improvements in patient outcomes.
Survival rates are probably in the 5 to 10%. And what it would mean, just to double that, right? Just to go from 5 to 10% to 10 to 15% would be a huge win. And to be a part of something of a broader initiative that did that would mean everything, because this is such a malicious disease.
There is this sense of dreaming and dreaming big and, making a difference, pushing things forward.
It has been really one of the greatest professional privileges of my life to work with such motivated students with fertile minds who are willing and able to take a chance. And my goal is to facilitate them getting to the next stage of their career. I chose to move into brain tumors and to move into glial development because it's an underserved area that could have a huge impact. To know that your work can impact people's lives is the biggest thing of all.
Awesome. At this juncture, I'd like to introduce his lead nominator, Dr. Malcolm Brenner, who is one of our finest faculty, distinguished faculty at Baylor, and a good friend. Malcolm.
Well, it's a pleasure to introduce Ben to you. As you heard from the video, the majority of neuroscientists have focused on neurons, but Ben has always been very independently minded, as it were, and his interest began with glial cells almost as soon as he arrived. Initially, he was focused on looking at how they developed normally, what their hierarchy was, but this very quickly evolved into an interest in what molecular and genetic events were involved when they went bad, when they started to form tumors. And in a series of really very important papers published in major journals, he identified several pathways, the means by which the malignancy occurred, that are already leading to the possibility of new agents that are going to be much more specific and much more effective than the currently limited, the limited ones that are now available. This work is and remains very important, but it's probably his more recent work that will have the greatest potential effect on human health. And that is, as he mentioned, the interaction between neurons and glial cells. But he's talking not about just interactions at the single cell level, but at a much higher order of interactivity. We're talking about things like behavior, memory, and also cognitive function. This will lead to insights that haven't really previously been obtained into a whole range of neurological disorders. You heard Helen mention some of them, but in general, the neurodegenerative diseases and also probably some severe mental illnesses as well will all prove to have been at least partly soluble by investigating the glial component. This knowledge of new behavior will hopefully lead to new therapies that will go far beyond what we have available at the moment, namely things that affect neurotransmission, the immune environment, and so on. If you want to answer important questions in science, you have to get the answers fairly quickly. And to get the answers quickly, you need to have a team. And if you're going to translate that work into the clinic, that team needs to be very diverse indeed. And I would say that one of the big strengths of Ben is his ability to build a superb team, and he's built it and he's maintained it and he's extended it. And so I'm confident that those abilities all together will ensure that he'll remain, and his team together will remain in the forefront of this new field of neuronal and glial interaction. So it's with genuine pleasure that I learned that he won this award, and I'm very pleased to introduce to you and hope you'll congratulate Ben Deneen as he wins the Edith and Peter O'Donnell Award in Medicine for 2024. Thank you.
Wow, that was quite the video and quite the introduction. First and foremost, there's a lot of people I need to thank. First, I need to thank the awards committee, the O'Donnell committee, and TAMEST. This is a huge honor, probably the biggest professional honor of my life. First and foremost, though, I need to thank the postdocs, the graduate students, the collaborators who've worked with me over the years. It's their faith in me and their faith in the science that has really driven these projects, and I'm so grateful for that. I think secondly, I need to thank Dr. Brenner and Dr. Heslop for recruiting me to Baylor. I was just a kid from California who spent my entire life in California, who was working on weird embryonic chick spinal cord gliogenesis. And they saw a vision and they believed in me. And I'm very grateful for them recruiting me to Baylor and making this my home. Third is the Baylor College of Medicine. I'm so grateful for this institution, for nurturing me as a young PI. It has provided a fertile environment that has allowed me to grow and to evolve my research program from early chick development into brain circuits and brain function. Also, a lot of the people here today who helped me grow, Peggy Goodell, Brendan Lee, Marty, and so forth, it's a fantastic environment and it's such a great institution. Finally, last but not least, is my family. They can't be here because of kids and those kinds of things. But my wife, Jennifer, and my daughter, Madeline, and my son, Riley, I am so grateful for them tolerating me and for dealing with me over the years for all these things I've had to do to create this wonderful environment in my lab and to do this wonderful science. And briefly, I just want to say that it's very difficult studying glial cells. And I can see neuroscientists clutching their pearls whenever I mention glia, because glia are very much the dark matter of the brain. We know that they're there, we know that they're important, but we don't know what they do. And over the last 20 years, there's really been a renaissance, not just my lab, but a lot of labs around the world who've appreciated the roles of astrocytes in brain function. And how important these lines of communication are for brain circuits, brain function, and when those lines of communication are disrupted, diseases. Moreover, we've more recently moved into the burgeoning field of cancer neuroscience, where we have found that these lines of communication exist in brain tumors. They subvert brain circuits. Brain tumors act like vampires, and they suck off these nutrients from neurons, and they use them to grow. And if we can short circuit these interactions with neurons, we can better treat this malicious disease. So in closing, it's been a fun ride over the last few years, but I really feel like the best is yet to come, and the best is yet to come here in Texas. Thank you very much.
Thank you. We are now proud to recognize Dr. Ashok Veeraraghavan as the recipient of the 2024 Edith and Peter O'Donnell Award in Engineering. Dr. Veeraraghavan is a professor of Electrical and Computer Engineering Department at Rice University. He was nominated by Alan Bovick at the University of Texas at Austin, member of the National Academy of Engineering. We'll now watch a video and learn more about Dr. Veeraraghavan and his work.
The act of composing is a very calming, slowing thing. I don't take a lot of pictures, but I do enjoy taking pictures. Part of it there is the creative process. Because I understand the science of photography, the creative form is a little easier for me to address and engage with. Computational imaging is the field where we think about how best to extract information from light. We do this by combining advances in optics, the electronics, the sensor that you use to capture this image, the algorithms. And we combine these advances together to create holistic imaging systems that can go beyond the limits of what conventional and traditional design systems and philosophies can achieve. Scattering, I believe, is the holy grail problem in imaging.
There are so many things we want to see, but they are mired or behind something, which is a scattering media. Could be fog, could be smoke, could be human body.
You need new techniques to undo these effects of scattering and be able to see through scattering media regardless of application.
Perhaps we will have car headlights which can see through fog.
Can I image the blood vessels through the skin tissue without making a cut in the tissue.
A firefighter entering into a room filled with smoke could potentially one day start wearing goggles that allows him or her to see through that scattering media and have clear visibility.
It's considered one of the hardest problems in imaging, and he's going for it.
One of the earliest problems that my lab got started into was the idea of looking around the corner. Can we capture sufficient information so that you can undo the effect of the scattering, and walls like these around me could turn to look like mirrors so that you can actually look around corners? We created a lensless camera. You have a bare image sensor and you have some very thin optic that's placed directly on top of the image sensor, and most of the focusing is done computationally in algorithms, and you create pictures. We adapted the lensless imaging technology for microscopy so that we could just take the microscope and place it on the slide, because the microscope is now as small or as big as the slide itself. We also worked on new microscopes that have a better trade-off when it comes to spatial resolution versus depth of field, so that you don't have to do scanning. Then it could really open up new kinds of applications, things that we cannot imagine today.
He is bringing new talent into the mix.
Science is a team sport.
The most impressive thing about Ashok's lab is you are really free.
He's really good at both the science and the ideas that come from it.
He pushes them to step outside their comfort zone constantly.
Not every idea you have leads to an aha moment. Life without problems is boring. I'm an engineer. I see a problem that has a compelling need. That's what excites me.
To introduce Dr. Vera Gahavan tonight, we are pleased to have Dr. Moshe Barty of Rice University join us. Dr. Barty is a member of the National Academy of Engineering, the National Academy of Sciences, and a fellow of the Royal Society of Fellows. Dr. Barty, please come to the podium.
It gives me great pleasure to introduce my colleague, Ashok Veeraraghavan. I'll just call him Ashok to save time. I'm particularly Rice University, we are very proud of him. We are very grateful for TAMEST and for the O'Donnell Award Committee. I'm particularly pleased because I've been his unofficial mentor for several years now at Rice. Ashok research focuses on making the invisible visible by co-designing sensors, optics, and machine learning. Notable inventions include NLOS, the first camera to look around corners, flat scope, the world's thinnest, lightest microscope, WISH, highest resolution wavefront sensor, SAVI, first and only sub-diffraction limit long-range imager, and deep DOF, a microscope that breaks the depth of field versus resolution trade-off. Let me explain a little better. I'll read the nomination. Cameras have played a key role in a host of major scientific discoveries. Despite its impact, the basic camera principle, lens and sensor in a box, have remained consistent from 15th century drawing of Leonardo to the modern smartphone camera. Ashok's research breaks free from this long-standing tradition and reimagines the camera to be a part of a computational system, one that processes light to extract information. He redesigns cameras from the ground up through creative co-design of optics, sensors, and machine learning. His lab has made a series of remarkable inventions that defy traditional limitations. Hopefully some of you have been here in the morning and you heard the talk where he described his works in depth. Ashok?
Thank you, Moshe, for such a warm introduction. First of all, I just want to thank the TAMEST and the O'Donnell Foundation for this award. It means a lot to me. I want to thank first Rice University for giving me a job that I didn't think I was able to do, and then providing me the environment where they taught me with the colleagues around me. They taught me that this is a job that you can do, and they showed me that it can be fun. And so I thank Rice and all my environment around me at Rice for that. I want to especially thank Richard Baranowicz, Ashu Sabharwal, and Jacob Robinson, who have at the same time been my mentors, my collaborators, and my co-conspirators as we go around trying to solve different problems. And so I especially thank them. I want to thank Al Bowick, who graciously nominated me for this award, and for all the others who helped with this nomination. I want to thank my family, my friends, my wife, and my 5-year-old son for giving me some perspective, keeping me on the straight and narrow. So thanks. Thank you, everybody.
We are now proud to recognize Dr. Vincent Tagliabracci as the recipient of the 2024 Edith and Peter O'Donnell Award in Biological Sciences. Dr. Tagliabracci is Associate Professor in the Department of Molecular Biology at UT Southwestern Medical Center. He was nominated by Dr. Eric Olson as UT Southwestern Medical Center also. Dr. Olson is a member of the National Academy of Medicine and the National Academy of Sciences. Now, let's learn more about Dr. Tagliabracci and his work.
Science is hard. 90-some% of experiments that we do fail. If you come to work and you're excited about what you do and you have a good, supportive team around you, you're put in a situation to do really good science. We're trying to understand how enzymes work. Especially weird enzymes.
There is a very large family of enzymes called protein kinases. They regulate all sorts of biological processes.
A kinase is basically an enzyme that our body produces. They bind the energy source in the cell, and they transfer a phosphate group onto another protein.
We like the weird ones, like we like the ones that other people don't think about or other people think aren't kinases.
We try to work on the kinases that look like kinases, but we're finding that they don't do that reaction. They don't transfer the phosphates. They do something completely different.
What Vinny has done is to study pseudokinases.
Something might look like a kinase, and that's our starting point. And then we end up figuring out it's a different type of enzyme.
People think of them as like dead enzymes. People think they don't have any activity. And a couple of times now we've proven other people wrong.
Every once in a while we get lucky and some of these proteins turn out to be very important in different human diseases. In the case of the coronavirus, when it comes into our cell, it releases its genetic material in the form of RNA. And because it's viral RNA, it needs to disguise itself. Coronaviruses have this cap structure. This cap structure is a form of camouflage that the virus has figured out a way to add to its genetic material to prevent our cells from recognizing it as foreign. And it does this through this atypical, kind of weird pseudokinase.
By knowing what the enzyme does, how it does it, then we can design and discover drugs to target it.
With the hope of developing another antiviral used to treat COVID-19 or COVID-25 or whatever next pathogen emerges. I think mentoring is the most important thing that I do.
I think he gives us a lot of freedom to pursue what we want.
Vinny is a great mentor. He will always have your back.
He's not someone who would micromanage and be like, you have to do X, Y, and Z, my way or the highway. That's not Vinny.
Just like my mentors mentored me, I think it's time for me now to pass that on to the next generation.
Vinny is really a special scientist.
I get up every day, I come here, it's like a playground to just discover new things. It's exciting to think about, if we know even more than we know now, how much further medicine will come.
Dr. Olson, would you please join us up here on the podium?
All right, what a great night. So I want to congratulate Vinny Tagliabracci. I also want to congratulate his mother, who's been sitting next to me at dinner. So I am thrilled to introduce Vinny as this year's Edith and Peter O'Donnell Awardee in Biological Sciences from TAMEST. It is fair to say that Vinny is among the greatest biochemists of his generation. Protein kinases are enzymes that have been studied for decades, and they play important roles in many physiological and pathological processes. The textbook view is that these enzymes transfer phosphate from ATP to protein substrates in a process termed phosphorylation. Vinny's work has overturned this paradigm, demonstrating new catalytic activities of atypical protein kinases or pseudokinases, which he also refers to as zombie kinases. Through creativity, keen insight, and a rigorous combination of biochemistry, structural biology, and cell biology, Vincent Tagliabracci discovered diverse and unanticipated biochemical activities of non-canonical members of the protein kinase superfamily, which were previously thought to be inactive. Through the course of his work, he has discovered an amazing array of functions for the previously unrecognized family of proteins, with functions ranging from bone disorders to bacterial pathogenesis, and most recently, COVID-19 infectivity. Vinny Tagliabracci discovered that the predicted inactive pseudokinase called cell-O adds adenosine monophosphate, also known as AMP, to proteins in a process called ampylation, which he showed plays an important role in antioxidant functions in bacteria and yeast. And I'll note that Kim Orth, another Edith and Peter O'Donnell awardee, has also performed beautiful experiments on ampylation. Vinny also discovered pseudokinases responsible for Legionnaire's disease and the virulence mechanisms of plant pathogens that devastate crops. Most recently, as you heard in his lecture today, Vinny solved a 40-year mystery as to how the coronavirus caps its RNA, and he showed that a pseudokinase encoded by the SARS-CoV-2 virus, also known as COVID-19, controls this process and is required for SARS-CoV-2 replication. And so this has obvious and important implications for antiviral targeting of this process to treat COVID-19. Through these and other discoveries, Vincent Tagliabracci has revealed an unexpected goldmine of eukaryotic and prokaryotic kinase-like proteins with far-reaching functions in physiology and disease. When I asked him a question today after his lecture, he was coy about how many pseudokinases remain to be discovered, but I'm confident there are many more that will keep him occupied for the rest of his career. So we expect these discoveries are only the tip of the iceberg, and I can only imagine what comes next for this once-in-a-generation scientist. So please join me in congratulating Vinny Tagliabracci as this year's Edith and Peter O'Donnell awardee.
Well, I don't know how to follow that up. First I'd like to start by thanking the folks at TAMEST for putting on this wonderful meeting for the past 20 years, especially the founders. I think this is a very special meeting. I think it's amazing what younger generations of scientists are capable of doing and getting the recognition for it, especially in the state of Texas, where we have the support of our seniors and of the state as a whole. I'd next like to thank the O'Donnell Foundation for especially Peter and Edith O'Donnell, who unfortunately I never had the pleasure of meeting, but I've heard remarkable things about them. And I just want to really express my gratitude to the O'Donnell Foundation for this award. And to that end, I'd also like to congratulate the other O'Donnell awardees. It's great to share the stage with you guys. And congratulations. We'll have to have a few drinks after we get done with this. In the video, I mentioned mentoring. And I think part of the reason why that's so important is because I've had such great mentors over the years. It started when I was a graduate student with Peter Roach and Anna DePauli Roach, who's with us today, who made the trip from Indianapolis. And then Jack Dixon when I was a postdoctoral fellow in San Diego. And then Eric took a chance on me, hired me as an assistant professor in 2015. And his mentorship throughout the whole process of me growing as an assistant professor has just been remarkable, and I really want to thank you for all your support. And it doesn't just start with Eric. Joan Conaway, Kim Orth, Dr. Michael Brown, just the entire leadership at UT Southwestern, they make it easy for junior scientists to do science, to explore their curiosity, to come to lab and have fun, take chances, and not have to feel scared to try to make discoveries. So I just really appreciate the support of UT Southwestern, which is hopefully my home for a long time. I'd also like to thank my family and friends, my beautiful mom who came here all the way from Canada. I love you so much. We have a very small family. Lost my father a few years back, so Ma, thank you for making the trip here and making this a very special day for me. And lastly, all this work that I'm getting credit for standing up here is really not me. It's the people in the lab that do the experiments. So I have to give a shout out to them, and really in gratitude to all the hard work that they've put in over the years. So I'll end there, and thank you all for coming, and hope we have a great evening.
Thank you. Next, we'd like to invite Michael McPherson to come to the stage to introduce our next recipient. Dr. Michael McPherson is the Provost and VP for Academic Affairs at the University of North Texas, and we welcome you up here. You're hidden in the lights. Welcome.
Good to see
Thank you.
Good evening. On behalf of the North Texas community, University of North Texas community, let me express just how proud we are to have TAMEST recognize Dr. Shin-Chin Ma as the recipient of the 2024 Edith and Peter O'Donnell Award in Physical Sciences. Dr. Ma is professor and Welch Chair in Chemistry, Inorganic and Materials Chemistry at the University of North Texas. He was nominated by Dr. Pamela Padilla, Vice President for Research and Innovation at the University of North Texas, and you'll be meeting Dr. Padilla here shortly. As you'll see, Dr. Ma is a remarkable scholar and educator who has shared his innovative and cutting-edge thinking with students, with colleagues, with the broader community. He has more than 230 papers in national and international journals. His work has been cited more than 24,000 times, putting him in the top 1% of researchers in his field in this regard. In fact, he's been on Clarivate's list of highly cited researchers every year since 2014. I think you'll be as impressed as I am with this remarkable scholar-educator. Please enjoy this video about Dr. Ma and his work.
My research was primarily inspired by the BP oil spill. That's caused a lot of ecological disaster. That's how I started my interest for water-related research. If we want to remove the oil from the ocean, right, it's a very complicated environment.
Dr. Ma is a very creative chemist. And what he is doing is actually developing these porous polymers that can capture molecules that shouldn't be within the environment.
Nanoporous materials can be selectively created so that they will capture specific materials.
We want to capture the contaminants in the nanospace of the porous material.
Uranium, even hydrocarbons from oil spills.
Mercury, PFAS, the forever chemical.
Think about the things we don't want to be exposed to. How can we get them out of the environment?
The nanoporous materials are excellent tools.
We can put all kinds of hooks on the nanospace of those porous material to hook the targeted contaminant. They can have extraordinary high surface area, which is 1 gram of the material. It's comparable to 2 soccer fields. That means we can use the materials to store a lot of gas molecules, for example, natural gas, hydrogen, and also CO2.
We can put drug molecules in there, we can do gas storage and separation, we can do catalysis.
We can also extract the useful stuff from water.
The molecules that are being captured through the technology that he's developing can then be utilized for energy.
The uranium in the ocean can provide the electricity for human beings over 20,000 years.
He thinks about what can we do as scientists that could positively impact society.
Some of my relatives from China, they got the cancer, from the contaminated water. This is actually an issue for a lot of people. My dream is I could develop some materials to get some clean water.
What inspires me in the laboratory is the impact that I can have in the future.
Seeing that technology go from a lab to all the way to the being applied in real life is what motivates me.
Dr. Ma is an excellent advisor and leader in the lab.
He's like a really great mentor. He's also very self-motivated, which motivates us also to really work hard and get some good research.
The students and the postdocs, they make my research, my ideas happen.
He's actually addressing something that's fundamentally important, which is how do we deal with the molecules that we put out into the environment.
My dream is to use my expertise to do something which could be useful for humankind to solve some problems.
Dr. Padilla, please come to the podium to introduce Dr. Ma.
Good evening. It is my absolute honor to have nominated my friend and colleague, Dr. Shen-Kui Ma. He is, like I said, an incredibly creative and innovative chemist. I learned first about his work when he became, we recruited him away from Florida, yay, so that's great. And I learned about his work listening actually to a student. So a student was presenting research and we're presenting these beautiful molecules. If you went to his talk today, he has these really elegant molecules that they're developing. The student was so excited and to talk to me about this work, and so I started digging a little bit more, and I asked Dr. Ma to send me some of his papers. I'm a geneticist, but I wanted to read about his organic chemistry. And what he's doing actually could impact all of us. So we as humans have an impact on environment. We accidentally have oil spills. We produce molecules that lead to things like mercury within our environment. and as well as we need to mine materials for the things that we need within society. Additionally, there are some molecules that are rare that we need within to help within society, such as lithium, gold, etc. And what he is doing is developing these porous molecules and thinking about the space, and he's also looking at biology and what proteins have already done and what they have solved in terms of being able to capture and interact with metals. And so this is someone who thinks about and looks at another field, and then how can we use it to make an organic molecule to remove things like mercury in the environment, to sequester hydrocarbons, to perhaps get lithium out of environments so that we can then use them for purposes that we want. So that's incredible. And so when I learned a little bit more about his work, I was really intentional about nominating him for this award. So let me introduce to you the creative chemist from UNT, Dr. Ma.
Thank you, Mike and Pam, for the wonderful introduction. Also, thank Pam for the kind of nomination. I'm really deeply honored and also profoundly grateful to receive this 2024 Edith and Peter O'Donnell Award in Physical Science. To be honest, this is the highest honor so far received for my academic career. This recognition is not just for my personal milestone, but also is a testament to the dedication and support of my current and former graduate students, postdoc, visiting scholars, and collaborators, which have played a very important role in my whole academic journey. I'd like to first thank the support from my family, my wife, my two boys, Wilson and Alvin, particularly my wife for her support since my PhD period. I remember she told me one night, I woke him up by sleep talking, picked the pink crystal out. The pink crystal is the cobalt compound in my first JAX paper, actually. Of course, yeah, it's very important because which laid a foundation for my pursuit of academic career. As a material chemist, I always wish to do something and help to solve some problems for our society. And I'm very glad that some of our materials now can outperform some of the bench materials in water treatment. And then now we're trying to do something more to develop a new type of functional material to solve some more challenging issues like the forever chemical PFAS, particularly short-term PFAS. And also we want to develop some materials which can scavenging the toxic species in our body, because there's so many toxic species in our body. And moving from Florida to Texas, I have been fortunately to be provided a lot of more resources to approve those goals. Thanks to the great support from UNT and the chemistry department and also the Award Foundation. Last but not least, I'd like to express my heartfelt gratitude to the O'Donnell Foundation and the TAMEST for this incredible honor. Thank you all. Have a good night.
To introduce the final recipient, please welcome to the stage Vanessa Weich, Director of NASA's Lyndon B. Johnson Space Center. Vanessa.
Good evening. I have the distinct honor of introducing Dr. Kimberly Humbuchen, a remarkable engineer, brilliant innovator, and visionary leader. Over the course of her 20-year career as a robotics engineer at NASA's Johnson Space Center, Kimberly has held several roles and has developed human-robot interaction techniques and tools for the Robonaut and Centaur robots, the Space Exploration Vehicle, and a bipedal humanoid Valkyrie, among others. She currently serves as Deputy Chief for the Software, Robotics, and Simulation Division in the Engineering Directorate at NASA, where she oversees technology development and system management for robotics, flight software simulation, and crew countermeasures. Kimberly's research on human-robot systems could prove to be important for NASA's space exploration as we return to the moon and our Artemis missions as we then venture on to Mars. I would also be remiss to not mention that Kimberly and I share a Conway connection, as she is a native of Conway, Arkansas, and I'm from Conway, South Carolina. In her early elementary years, during a solar system lesson on Jupiter, it captured her attention, and it sparked her interest in space. And to let her tell it, she fell backwards into robotics. And today she finds herself named as one of the 25 women in robotics to know by RoboHub. And she's recognized for her outstanding achievements and groundbreaking innovations working with humanoid robotics for space exploration. On behalf of NASA's Johnson Space Center, we're so very proud of Kimberly and this very well-deserved recognition. I want to express our sincere thanks for the award recognition from the foundation, and to also say to Kim that we admire her and we're just so very proud. I want you to now take the opportunity to learn more about Kim and her work through this very video.
You drive into the gate, and there's this incredibly very large rocket. And it's like, I'm coming to work at NASA. Everybody's here for the mission. We want to make sure that NASA is advancing space exploration. It is inspiring. Here at Johnson, our robotics group is focused on human-robot systems. All of the places that we'll be going for exploration will have really large time delays compared to what we experience here on Earth.
Kim's work has enabled operators on the ground to remotely operate and oversee robots on other planetary bodies, and that can be on the surface of the moon, where the time delay can be on the order of seconds.
And then for Mars, it's between 7 minutes and 42 minutes round trip. We really need to understand how to work with that time delay. Robotics is kind of the solution. Supervised autonomy is being able to interact with these robots remotely, but not having to control every aspect that they do.
The more you can add that higher level of autonomy, the more you're going to be able to get done.
So we need these robots to really operate more autonomously than they do now. So that's what we're really moving towards.
Allowing our robots to execute tasks with minimal oversight has been a major innovation and something that Kim has worked very hard to achieve.
Kim's contribution to what we call affordance templates is, I think, really critical to the success of robotics long term.
We wanted to create something that allowed the robot to use an object to complete a task.
Could you open up a door? Well, how do you communicate that to a robot?
This affordance template for the valve actually tells the robot, here's how you use the valve to close the valve, to allow the robot to say, oh, there's the valve. The valve's not the same size as my template. Let me resize my template.
So these affordance templates, if you will, is describing tasks in ways that you and I as humans could understand.
So you're affording the robot the ability to complete this specific task. On Mars, you would not have to create a specific robot for each system you've got. We could have these types of robots do lots of different tasks. Robots are great for dull, dirty, and dangerous jobs.
There's already been that technology transfer, if you will, into the aerospace world. Exploration of oil and gas,
There's autonomous vehicles in doing mining now.
I see a lot of trajectories for her work.
Kim's leadership is ensuring that we are developing the capabilities of software, robotics, and simulation to help NASA be successful.
Everybody at NASA centers is just completely dedicated to this work and to advancing NASA's mission. It just was what I was born to do.
Now, please welcome Kimberly's nominator, Dr. Stephen Frederickson. He's Chief of the Software, Robotics, and Simulation Division at NASA Johnson Space Center.
Thank you, Vanessa, and thank you so much for the opportunity to introduce Dr. Kim Hambucken as the 2024 O'Donnell Award winner in the Innovation category. I've had the privilege of knowing Kim for actually over 20 years. I first met her when she was a NASA Graduate Research Fellow in our Dexterous Robotics lab. Later got a chance to know her as the postdoc fellow in the same lab, and eventually she converted and became a permanent NASA civil servant. Before I get into some of the rest of her career and kind of how it led to the technology development for the award, I wanted to maybe share a little bit about her upbringing. And as Vanessa mentioned, she grew up in Conway, Arkansas. And in fact, she has a family of 5, all of whom are here along with their spouses. So we've got Kim's dad, Ray, and mother, Donna. And we're at table 7 off to the right side of the stage there from your vantage point. Kim's sister, Lisa, and husband, Aaron, also from Conway, Arkansas. And then Kim's brother, Scott, and wife, Lori, from Little Rock, Arkansas. So they all made the trip from Arkansas, and we're really pleased that you did. Welcome, and we're glad to celebrate with you Kim's accomplishments. So going back to her career, when she became a civil servant and basically began that service to the nation, Kim has had, as you might expect, a career of rapid progression and a very impressive set of milestones. I won't read the whole resume, but just a couple of highlights. Very early, she became the robotics chief of the branch chief of our robotics systems technology branch, where that dexterous robotics work that Vanessa was describing is really housed. You see both dexterous robotics and some of the rovers in the video. That is that branch. More recently, she took a stint over into the International Space Station program as the deputy manager for the Systems Engineering and Integration Office, and that's an organization that has a lot of responsibilities on Space Station, but among them, managing those robotic arms that are sort of iconic of Space Station operations and maintenance. And perhaps the best part of her resume was about a year ago when I was able to draw her back into engineering, back into our division as our deputy division chief, as Vanessa mentioned. It's really been a privilege to have her back and to work with her on a day-to-day basis in both technology and the organizational leadership. I'll get to the technical part of that in just a second, but if that resume sequence is not impressive enough, I also have to mention that she's a very accomplished tap dancer. So a lot of talent in Kim. Thinking about the technical side, Vanessa just alluded to it now, and also if you heard Vanessa's presentation this morning, at the Johnson Space Center, we're all about leading human spaceflight. And that means that our robotic work is oriented toward assisting and enabling astronaut crew members as they go from low Earth orbit to the moon and onto deep space. And as we do that, and Kim, if you watch the video closely, you see that one of our challenges is to take what is a terrestrial problem of using robots for the dull, dirty, and dangerous jobs. But as you do that further and further away from Earth, the options of the kind of the balance between teleoperation and autonomy becomes more challenging, because direct teleoperation is not going to work over seconds of time delay, let alone minutes of time delay. And that's where Kim's affordance templates work is really appropriate, because you want to be able to command robots at the level of tasks and objects not controlling individual joint angles or joint forces or joint velocities, for example. And so that is really the crux of her work. She'll have a chance to describe that in more detail tomorrow. I hope those who are able to stay till tomorrow will get a chance to hear that, because it really is, very innovative, and it's widely used in robotics research. And since I'm also a federal employee, I can't get up to a microphone and a podium without showing at least one slide. And I want to share one more aspect. I've already, if we could bring that up, I already had a chance to introduce Kim's family from Conway, Arkansas. So now I'm going to show you her family of robots. If you look closely in the center of the display, you see Kim crouched down. And I bring this up not just because we like to brag about all the robots we've built, but to highlight, look at how different they look. There's dexterous robots, there's rovers, there's forms that you might not even think of as robots. But imagine if you had a subset of those on a lunar surface or a Mars surface. What makes Kim's research really valuable is you don't want to have all of our ground controllers be experts in the intricacies of all of those individual robots. You want to be able to command them at the task level, and that's in fact what Kim's research is all about. So with that, I'd like to go ahead and invite Kim to come up to the stage, and as she does, please join me in congratulating her on her award. Congratulations.
Thank you. So first, I feel like I need to go ahead and apologize to Steve, the lead of the film crew, for not inviting him to my TAP class to film a little introduction. After seeing some of the other videos, that's the missing piece. I would really like to thank TAMEST and the committees and the O'Donnell Foundation for this award. It was completely unexpected for me, but also really exciting. And it's made me kind of take a step back and look at some of the work I've actually been working on myself over the years. As I think a few people up here have already said, robotics is a team sport. And I would be remiss if the first people I didn't thank were all of my coworkers and colleagues who I've been with over the years. They have gotten me through some hard times. I have helped them through some hard times. And we really all kind of come together to make these things happen. I would also like to thank, two men in my life who I claim I wouldn't be at NASA without. One of whom was my PhD advisor, Alan Peters, who lives in Nashville and is not here tonight. The other is Rob Ambrose, who is an Academy member who is here tonight, somewhere in the crowd. All I see are blinding lights. Rob spent a good portion of my career guiding me, supporting me, and really pushing me. And I kind of didn't know what he was doing behind the scenes, but it's all becoming a lot more clearer now as I'm getting older in my career. So I want to thank Rob. I've gotten to thank him profusely at a separate event, so I won't belabor you the details on that. I would also like to thank Stephen, is he behind me, for nominating me. We're a pretty new division chief deputy pair, and it's been a pleasure working with you over the last year. So I'm very excited for us to continue doing that. And I have a whole lot of new things to learn from him as well. I would also like to thank Vanessa. I'm so excited that Vanessa was here and got to introduce Stephen. Vanessa's probably my favorite center director, and I'm not just saying that. And I've gotten to know her a bit over the last few years too. So, but she's a fantastic role model for women in aerospace. And so it makes me really happy every time I see Vanessa talk at an event for us. And so I'm very, very excited that she's here. I would like to thank my family, who are all here at the table. When I found out that, I assumed my parents would want to come. When I found out that my siblings also wanted to join, my siblings who I kind of hated when I was a young girl, and they kind of hated me when I was a young girl, that they really wanted to be here. I was very excited. I do know they're proud of me, and I'm really, really impressed at how proud of me they are. And then last but not least, I would like to thank my parents, who I am so excited were able to come and be part of this. They've been just about the best parents a girl who wants to go into engineering and work at NASA could have. Not once did they ever say, honey, do you think you really want to do that? Maybe we should move you in another direction. When I wanted to be an engineer and I was going to go to Duke University, which I didn't go to, and all of the different summer things I wanted to do, they just totally supported me. And I definitely, I say I wouldn't be at NASA without Rob Ambrose and Alan Peters. I definitely wouldn't be at NASA and be standing up here without those two. So thank you, Mother and Dad. And thank you again to TAMEST.
What a wonderful group of rising stars. Let's give them another hand, please. We heard it earlier. I'm going to repeat it again. When you see this young crowd, you realize the best really is yet to come. Tonight, you witnessed the best of Texas, generosity and creativity. We'd like to once again recognize the generosity and the forethought of Edith and Peter O'Donnell and their foundation for making these awards possible each year. We hope you'll help TAMEST continue this initiative by making a donation to support the O'Donnell Awards. You can make a gift online at the TAMEST website. And I'd like to now turn it back to Dr. Thacker.
Thank you, Mr. Thompson.
Thank you, Dr.
Great.
Thank you.
Great. Thank you, Mr. Thompson, again, and congratulations again to all of our awardees. Great. Now comes the next step. Nomination for the 2025 O'Donnell Awards are now open. And if you don't apply, you are not going to win. So get yourself nominated, tell your colleagues, or nominate someone else. And we encourage all of you to recognize outstanding achievements of rising star researchers and nominate them for these awards. This concludes tonight's celebration. The conference program will convene tomorrow morning here in the Grand Ballroom for breakfast. Breakfast will open at 7:30 and program will begin at 8:30 a.m. And we will have breakfast session speaker, Chris Urmason, CEO and co-founder of Aurora. The reception tonight will continue until 10 p.m., so enjoy. Have a wonderful evening. Thank you all.